Hello everyone, welcome to our channel Physics for AP. So I am wearing spectacles, so as I have a defect, so I cannot see the far objects. So I have a defect there. Can you tell me the defect what I have, as I cannot see the far objects here? Yes, it's called myopia. And can you tell me the correction of the lens? So what are the lens which I am wearing? So the spectacles which I have here is a lens. So what type of lens is used to correct the defect myopia? So it's a biconcave lens. So here today episode we are going to discuss about the structure of eyeball. So what are the parts of the eye, and we are going to see how the image is formed inside our retina and the defects of eye and how are they been corrected here. So what are we waiting for? So let's move on to our channel Physics for AP. Let's discuss the structure of human eye. So lens is a transparent material which is bonded with two curved surface. So even we also have a lens in our eye. So let us see the structure of eye. So we are moving to the eyeball. So the front part of the eye which we are seeing is called as the cornea, which protects the eyeball, and we have a colored part which is called the iris attached with the pupil, the black colored part. So this iris make the adjustment of the pupil to enter the light into it, and behind the pupil we have a lens which is called a biconvex lens, which is attached to the ciliary muscles. So these ciliary muscles adjust the focal length of the eye lens, which we called as accommodation process. So when we see the object which is far away, so the eye lens get relaxed, and when we see the objects which are near, so it gets contract to adjust the focal length of it. So the power of accommodation is nothing but the process of adjusting the focal length of the eye lens. So when we see here to our eyeball, we have the optical nerves which are connected to the brain. So the image which is formed upon the retina are being transmitted to the brain and make us view here. So we have a minimum distance to the object. So when we keep the object near to us, we cannot see it, but we have a minimum distance to see the object where it can appear clearly, which is 25 centimeters. So we call it as near point or least distant vision. So the far objects which we want to see, so that starts from about 25 centimeters to the infinity. So when we get the defect of our eye, when we see it as a blurred objects, so when we are getting the blurred objects, so it means we call it as refractive defects, so which is hypermetropia, myopia, presbyopia and astigmatism. So let's discuss about hypermetropia, so which is also called as long-sightedness. So the person who can see the far objects but cannot see the near objects here, so they are being focused beyond the retina, so the eyeball becomes short. So to get the correct of the defect, so we use a biconvex lens. So the myopia, which is also called as short-sightedness, so the person who can see the near objects but cannot see the far objects. So the object the focus of the object falls in front of the retina, so that time the eye lens become elongated or stretched. Now to correct the lens, we use a biconcave lens over here. And presbyopia, so the persons who becoming aged persons, so as they cannot read anything which is present on their book, and also not even far away. So that means due to the overstretching of the eye lens, so they get weakened out and they cannot see the objects here. So for that we use a convex lens so that they can see the near objects, and we use a concave lens to see the far objects. So we use a concave convex lens, that is both bifocal lens, so that they can see the far objects and near objects also. Now astigmatism. So astigmatism is the person who cannot see both, just like presbyopia, but two visions of objects can be seen, as they have been focused on two different places. So to correct the defect over here, we use a cylindrical lens to correct the defect here. So let us see some of the important facts about the defects of eye. So here we have a ray diagram which is for the normal vision. So for normal vision, the image falls upon the retina, and we have rods and cones, that is the optical nerves. So as we have the optical nerves, so which are called rods and cones. So which are called rods and cones. So these rods are used to identify the intensity of light. So these are used to identify the intensity of light. So, and the cones are used to identify the color of an object or color of a light. So is it clear? So the image which is formed upon the retina is been observed by the optical nerves, which are called rods and cones, and rods function is to identify the intensity of light, and cones functions are to identify the color of the objects. So this is for the normal vision of a person. So here we have the ciliary muscles. So these ciliary muscles adjust the focal length of the eye, so which we call as accommodation, the process, and that focal length is adjustment between 2.27 centimeters to 2.5 centimeters. That is between these two only it is been adjusted over here. So the minimum focal length, the minimum is 2.27, maximum is 2.5 centimeters. In between these regions, the focal length of the eye lens will be adjusted. So how can we calculate these values? So as you can see by using the lens formula, as the image distance is 2.5 centimeters, that is the distance from the lens to the retina is 2.5 centimeters. It is exact, so there is no change over here. So we have the image distance as 2.5 centimeters, and when the object is at infinity, that is when it is far away, we have the maximum focal length as 2.5 centimeters. When you substitute and when you calculate, you will get the answer. And in the same way, when we have the near point, so near point is the distance at which then we can see an object clearly. The minimum distance at which where we can see the object clearly is called that near point. So that is 25 centimeters here. And we have, if you substitute that 25 centimeters, so we get the minimum focal length as 2.27 centimeters. So our eye lens has an adjustment of focal length from 2.27 to 2.5 centimeters. And when coming to the power of the lens, so the power of the lens, as we have discussed earlier, so power is equals to reciprocal of the focal length, right? So here, as it in centimeters, just 100 by f. So if you find out the power for this, we get the power as 44 diopter, and for this 2.5, that is 100 by 2.5, we get the answer as 40 diopter. So the power of our eye lens is been adjustment between 44 diopter to 40 diopter, and focal length will be from 2.27 centimeters to 2.5 centimeters. This is the ray diagram and the basic information for the normal visions. Okay, so when we get the defect of myopia here, so myopia is also called as short-sightedness. So here it has an adjustment of focal length, as minimum will be 2.27, obviously it will be minimum 2.27, but the maximum focal length will be less than 2.5 centimeters. So the maximum focal length will be less than 2.5 centimeters. So due to that, there is an elongated of eyeball, that means the eyeball gets expanded. So the person who are suffering from the myopia, that is those who cannot see the far objects, the eyeball gets expanded. And to correct this, we use a biconcave lens over here, so that the image will be formed upon the retina, the spot will form upon the retina. So this myopia defect occurs due to the children's those who are viewing more cell phones or computers, or if they study under the dim light, so due to that problems, we are getting myopia over here. And one more thing is hypermetropia, which is also called as farsightedness. So it has a minimum focal length which is greater than 2.27, and the maximum focal length will be 2.5 centimeters. So myopia is who cannot see the near objects. For that, the eyeball will become short. The eyeball will become short due to the person who are suffering from hypermetropia. The eyeball will become short over here. And to correct the defect, we have here the biconvex lens. So biconvex lens is used for the hypermetropia persons to correct the defect. And the reasons for this hypermetropia is when the person gets aging, that is from the adult age, when they are entering into the old age. So in the mid of the adult age, they get this hypermetropia. So that is, they get eyesight low as they cannot see the objects which are near to them. So they use this hypermetropia here. And coming to the presbyopia, as we have seen, presbyopia is for the old age person. So they use biconcave convex lens, that is concave and convex lens both they have. So they have the lens like this. So the lens which they are using it in the middle here, we have a convex lens for them, and here we have a concave lens for them. So both we are adjusted in the lens, so which is called as concave convex lens for the presbyopia people. So this is about what we have discussed about the structure of eye and the defects of eye over here. So regarding any doubts, please give your valuable comment, and I'll be waiting for your comments. And please subscribe the channel, share it to your friends, and enjoy your learning. Thank you everyone.